Quantum mechanics was crafted by some of the greatest minds of all time. Counterintuitive and revolutionary, it challenged all existing notions and theories of our universe. But who would dare challenge the work of such legends? The legend himself. You watch Schrödinger as he stands in his office, peering over your equations. You wanted to understand the inner workings of his new theory explained using a thought experiment. The experiment, now known as Schrödinger's cat, has become the most notable means of describing the weirdness of quantum mechanics. The story of the cat is simple. If a cat is placed in a box along with some poison, quantum mechanics dictates that the cat is both alive and dead, until we open the box and observe it. How can a cat be both alive and dead? You ask Erwin. He replies by explaining that the story is not about a physical cat, but that the cat is just an analogy for quantum particles. He picks up a piece of chalk to continue his explanation, when a porter rushes into the room with an urgent marked letter. The letter looks familiar. Schrödinger opens the envelope and looks inside. His eyes widen as he reads the document. Podolsky, Rosen, and I have issue with your recent theory and have crafted a counterexample. Communications to follow. Signed, Albert Einstein. Einstein lays out his issues with quantum mechanics as a thought experiment of his own. We start with two balls that are quantum entangled. We call them ball A and ball B. When ball A is red, ball B must be blue and vice versa. At any point, we do not know the color of either ball, we just know one will be red and the other blue. Quantum mechanics dictates that the state of the ball A is both red and blue at the same time. Einstein then asks to imagine two observers, Alice and Bob, floating very far apart in space. Ball A is launched towards Alice and ball B towards Bob. The problem now arises. If ball A reaches Alice first, she can look at it and determine its color. At that very instant, ball A not only chooses a color for itself, but also communicates to ball B what color it chose. Einstein calls this spooky action at a distance. He outlines that, as nothing can travel faster than the speed of light, the two quantum balls should not be able to communicate with each other instantaneously. Even if Alice had observed the red ball while ball B was at the other end of the universe, Bob's ball would turn out to be blue. Einstein states that the only way around this is to do away the fundamental idea of quantum mechanics, things being in two states at the same time. He holds the position that ball A is either red or blue, we just don't know which one it is. There is some hidden information that determines the state of the ball. Einstein calls this a local hidden variable. It simply means that the ball knows which state it is in, and there is some hidden variable that, if discovered, could let us know in advance what state the ball will be in. The state of ball B will also just be the other color. A challenge that will decide the future of physics. A debate that will shape the view of the universe. A theory that will pave the road to an equation for everything. But how do you, an unknown physicist watching from the sidelines, fit into this puzzle? You're the missing piece.